All right, what we're going to take a look at today is a little combination of the angle addition postulate and the segment addition postulate. These are going to be your first four examples that you see on Delta Math. So if you want to go ahead and pull those up, take a look at those. We'll work through these together. So what we have is we're asked to find point F on the line segment EG, given that FG is a measure of 8, EF is a measure of 2x plus 4, and EG is a measure of 4x minus 10. Now, I don't know that this is for scale because the F could be closer to the G, the F could be in the middle. We have no indications based on what this will be, so I just put the F anywhere on this line because the only information we're given is that it is on the line segment. So once we have these, and again, you may put yours at a different spot, that's fine, that doesn't matter. Once we have these though, what we can recognize is that FG has a measure of 8. EF has a measure of 2x plus 4. And then EG, which is the entire segment, has a measure of 4x minus 10. Now this one's a little bit different because a lot of what we've dealt with, the two smaller segments, the two parts as we call them, are adding into a larger segment and we had the number. But we still do the same thing when we have these. It is the segment addition postulate, which says two segment parts combine, in this case 2x plus 4, combine with together to make the larger segment, the whole segment. So in this case, the whole segment being 4x minus 10. We're still going to approach this the same exact way. We're going to combine like terms. We'll do whatever math applies. We actually have like terms on the same side here. We have 4 and 8, which is going to make 12. And we have 2x, doesn't have a like term. So we get here. And we want to get all the variables to one side, all the constants to the other. I personally like to have the larger variable pull the smaller, so I'm going to have the 4x pull the 2. 4x minus 2x is 2x. And on the same line, I'm going to perform the constant values, which is to move the 10 to the other side. We don't have this, but we do need to keep into consideration the fact that just because we're solving for x here, we actually can have negative numbers. This is nothing we're going to see on this particular one, but just keep that in mind. If we were looking for the length of the angle, which actually in this case we are looking for, that would have to be a positive number. So we have 2x equal to 22, so we're going to divide both sides by 2, and what we learn is the x value is equal to 11. It doesn't ask me for the x value here, though. It asks me for the length of EF. So if we look back at EF has a measure of 2x plus 4. But again, x is no longer x to us. X is now 11. So when we're asked to find this side, we end up finding that this becomes 22 plus 4, a measure of 26. So segment EF equals 26. You could check your answer by going through and plugging these in. For instance, this would be a measure of 26, which you can clearly see my stuff is not to scale now. But 26 and 8 would be a measure of 34. So that means if I plugged in 11 into this equation right here, I should also get 34. And 4 times 11 is 44. 44 minus 10 is in fact 34, like it's supposed to be. So you can always go back and plug in your answer. But again, we're looking for segment EF. That was just me checking the answer. Segment EF is 26. So the next thing we're looking at here is our angle measurements. And again, we're going to label these things real quick. Angle T, starting here, R going here, S here. So we're talking about this angle segment right there. This angle segment right here is the one that we're solving for. The angle segments that we have are Q to R to S. This is the larger angle. This is the larger angle we see right there. And we also know, based on our information, that this is 146 degrees. And then the last thing we have is QRT. Q to R to T, which is this little green angle that I'm trying to construct here. This little green angle has a measurement of 53 degrees. So again, this is the angle addition postulate. We're looking for this reg segment right here, given these two larger segments. Be careful that you do label well. I hope that this 146 doesn't throw anybody off. Remember, I have labeled this as this entire segment from here to here. Although it is only in that section right there, we have to know that that's what that is. So what we have is the largest angle, QRS, and we have the smaller angle, QRT, and then we have to take that away from our larger angle to find the remaining angle, because the two parts of our triangle, or excuse me, our angle, need to be equal to the larger piece. So 53 plus angle TRS should equal 146 degrees. Once we have this set up, all we need to do is subtract our 53 from both sides. And we learn that angle TRS is equal to 93 degrees. Always go back and look. There are no variables to solve here, but make sure that you actually solve for what you were supposed to. There it is, so I solved for the correct thing. Next, we're going to take a look at the relationship between the different angles that we have. Keep in mind, we're looking for vertical angles. We are looking for linear pairs, which are supplementary. If we have a right angle that's marked, we would also have complementary. But I don't see any right angles, and I don't see anything that says we have a right angle, so we won't be dealing with complementary here. So it's most likely a linear pair, which again is supplementary, or it is a vertical angle. So let's see what we got first of all. We've got angle E to H, E to H to D. So that correlates with angle 6. So what we're given here is angle 6, and we're told that this is 68 degrees. Next thing we're asked is to find the angle C, starts here, to H to F, which is right here. So the angle we're talking about is all of this segment here. We can clearly see that those two don't share a side, so this is not a linear pair. And they are opposite sides of our vertex across two straight lines, so these are vertical angles. So if EHD is equal to 60 degrees, that means that CHF, is also going to be equal to 68 degrees. And we've saved the best for last here. Angle A and angle B are supplementary angles. Keyword supplementary. Remember, supplementary angles are angles that combine to equal 180 degrees. Two angles that combine to equal 180 degrees. So I've just drawn a line here, and again, this is not necessarily to scale. I just put it in the spot. I don't know that A is bigger than B or what. So this is just kind of an arbitrary little drawing here, but my angle A is equal to 3x minus 12, and my angle B is equal to 4x minus 25. So I'm going to go ahead and label these two parts here, put them where they belong. A value is going here, 3x minus 12. Angle B is 4x minus 25. And we are told that these are supplementary angles. That's why, again, I drew a linear pair. Remember, just because they're supplementary does not necessarily mean they're a linear pair, but why not make it easier on myself? Second thing I want to point out is, let's identify what we're searching for on this. We're searching for angle B, not an x value. But the first thing we need to do is set up our equation. So since these are supplementary angles, they're going to combine to equal 180 degrees. So I'm going to go ahead and put my equals 180 over here on the right. And I'm going to add my two angles together. That would be angle A plus angle B, and set that equal to 180. Angle A is 3x minus 12. Angle B is 4x minus 25. These combine to equal 180. So I'm going to have to solve this equation that I created here. Also keep in mind, everything on the left side is on the same side, so we don't have to do any kind of crazy moving from one side to another. The 3x and the 4x are already on the same side, so all we have to do here is combine like terms. So 3x and 4x makes 7x. Negative 12 and negative 25 are also on the same side, so we don't have to do anything to get them to the same side. We just need to combine our like terms. Together they make negative 37. Our 180 is just tagging along as we go here. Next thing I need to do is gather my like terms, so the 37 is the next to go. So I add 37 to both sides. 180 plus 37 is 217. 7x equals 217. I need to divide both sides by 7. 7 goes into 21 3 times, and 7 goes into itself 1 time. So 3, 1, x is my answer. Yay for me, but put on the brakes. Remember what you're asked for. It's very unfortunate if you miss this with the number 31, because you did all of the hard work and didn't reap the benefit from this, because they didn't ask me for x. Remember, they asked me for b. So b was this angle measurement right here, 4x minus 25. So I'm going to rewrite this, 4x minus 25. But in place of my x, I'm going to plug in the equivalent, which is 31 in this case. And then I'm going to solve for the equation, the angle. This is equal to angle B. 4 times 31. 4 times 3 is 12. 4 times 1 is 4. So 12 and 4 is 124. No variables to deal with here. So 124 minus 25 is 99 degrees. So angle B is 99 degrees. So what we're thinking on, and if angle B is 99 degrees, supplementary means they add up to 180. Think about what the other side would be. It'd be 91 degrees. Excuse me, 81 degrees. Sorry about that. 81 degrees would be my angle A. If you wanted to check your answer, Plug it in. 3 times 31, which was x. What I'm doing here is just checking my answer. Minus 12. 3 times 3 is 9. 3 times 1 is 3. Minus 12. 93 minus 12, of course, is 89. So that checks out. All right. You guys have the rest of your assignment. Get to work on that.